Hey guys, how are you? My name is Navreman and today topic is cosmic microwave background radiations. Cosmic microwave background radiations (CMB radiations) is one of the most significant pieces of evidence supporting the Big Bang theory, providing a snapshot of the early universe. Here's a detailed overview of the CMB. The CMB is the afterglow of the Big Bang, the primordial event that created the universe. It is the faint cosmic radiations that fills the entire universe, originating from a time when the universe was just 3,80,000 years old. The CMB represents the oldest light that we can observe, and studying it allows us to understand the conditions of the early universe. The universe began experimentally, and even to the coast a universe to expand from a journey within a single solar system. Light traveling from Earth to Mars, interstellar travels poses for far greater challenges due to the vast distances involved. Here a comprehensive overview of interstellar travel. Proximal, the closest star of the our solar system, Proxima Centauri, and 4.24 light years away, equivalent to approximately 4 exist elsewhere in the universe. Here's an overview of the main approaches and consideration in the search. In this search, study for extremophile research on extremophile organisms that thrive in extreme conditions on Earth. Helps scientists understand the potential for life in diverse environments beyond and rapidly advancing fields to astronomy, providing insight into the potential of life beyond Earth and the diversity of planetary systems in the universe. Here's an overview. This is the most successful method for detecting exoplanets. It involves monitoring the brightness of a star over time. If a planet passes in front of the star transits, it causes a slight temporary dimming of the star light. By analyzing law of physics, as we know, as break down a fraction of a second after the Big Bang, the universe underwent periods of rapid expansion called cosmic inflation. During these times, the universe grew exponentially in size, smoothing out any irregularities and setting the stage for the formation of galaxies and large-scale structures. Expansion of the universe. The universe continues to expand today, with galaxies moving away from each other. This expansion was first observed by Edwin Hubble in 1929, leading to the formulation of Hubble law, which stated that the velocity at which a galaxy recedes is proportional to its distance from us. Cosmic microwave background (CMB) radiations. About 3,80,000 years after the Big Bang, the universe cooled enough of protons and electrons to combine and form neutral hydrogen atoms. This allowed photons, light particles, to travel freely, resulting in the cosmic microwave background (CMB) radiation. The CMB is a faint glow of radiation that fills the universe and provides a snapshot of the early universe, offering strong evidence for the Big Bang. In the first few minutes after the Big Bang, the universe was hot enough to nuclear fusion occur, leading to the formation of the lightest elements, hydrogen, helium, and trace amount of lithium. This process is known as Big Bang nucleosynthesis. Over time, gravitational force. gravitational force clung together. In the breakdown, a fraction of a second after the Big Bang, the universe underwent periods of rapid expansion called cosmic inflation.